to San Diego State University. My name is Dr. Alan Gons. I'm the chair of the Geological Sciences Department. And today, I'll give you a few minutes of brief introduction to the Department of Geological Sciences. First, let me congratulate you on being accepted to San Diego State University. It is such a great accomplishment, and we look forward to seeing you on campus in fall. As you'll see scrolling behind me, there's images of Hepner Hall, the Student Union, and the Centennial Walkway, three of the iconic locations on campus that serve as a welcoming environment to all of our students. And we hope that you'll have a chance to sit under the eaves of the Union, walk through Hepner Hall, and stroll across the Centennial Walkway as you come to our campus at some time in the near future. For now, I'd like to tell you a little bit about our department, our degrees, our faculty, our programs, and our activities. The department is the 5th oldest geology program in the state of California. We have turned out geologists for decades that are serving in various roles, which I'll tell you a little bit about in a minute or two. But for now, a little bit about our programs and the fundamentals of our programs. All of our programs that we offer are founded on the fundamental foundations of geological sciences. And in that is field work, lab work, and courses. And they're integrated so well throughout the department that all of our students have a chance to go out in the field. All of our students have a chance to do research. All of our students experience geology through doing. And that is the best way to learn geology. Now, let me tell you a little bit more about our program and the types of degrees that we offer. And now for a little bit about our programs. The department has 5 different degree programs at the BS and BA level. We offer a BA in General Geological Sciences, and we offer 4 BS degrees: General Geology, Environmental Geology, Geological Engineering, Paleontology, and then a BS in Geophysics. Now, each one of these degrees is structured so that you take almost all of the same classes up until the very final year, and then you specialize a little bit. So to be with a big cohort of all the geology majors, regardless of what your sub-major is or whether you're BA or BS. In addition to those majors, we also offer minors. A minor in geological sciences, a minor in oceanography, and a minor in clean energy. The clean energy minor is actually run through the environmental sciences program, which we have a sister degree in, hosted within the department. And you can hop back onto the Explore page and learn more about the environmental science degree if you'd like. Now, like I said earlier, our programs all start with a foundational understanding of broad sciences, so math and chemistry and biology and calculus. And then from that, we build on top of it the understanding of geological sciences through courses like mineralogy and petrology and structural geology and sedimentology. And then ultimately at the very end of the degree, we have a capstone type experience, which is a senior research project that you pair off with a faculty member, and you learn about how to integrate all of the concepts of geology that you've learned in your time with us to be able to pull together the entire story. Because ultimately, a lot of geology is about telling the story of a place. And in that light, especially with our BA, we encourage students to go out and focus on some other aspects of the university. So with our programs, we actually encourage students to go out and explore other aspects of the university. Some of this is through the general education requirement that we have for all majors across the university. But we have ways to take those general education requirements and have them augment what it is that we do within the degree. So we encourage students to learn more about archaeology and anthropology, more about history, more about public health, to actually create more of an interdisciplinary program by using the aspects of general education to augment the degree that we have. Now, you may be asking yourself, great, I've got this degree in geology, or I want to be a geologist. Well, what can I do with a degree in geology? Now, there are many different things that you can do with a degree in geology. First, you can do geology. That seems pretty obvious, but what is it that a geologist does? Well, geologists are really important in understanding climate and how the Earth works when we start to think about hazards. So things like impacts of storms, earthquakes, tsunamis, climate change. All of this is related to earth science and geology at some level. We can also take the understanding that we gain from geology to help make our infrastructure better. So our geological engineering program trains geologists to actually understand the earth and link that to how to make a building stand and how to make a building withstand an earthquake and how not to build your house on top of a landslide or a hill slope that's moving down slope. When we start looking at things like geophysics, we can use those degrees to understand the fundamental structure of the earth, to understand how earthquakes happen, to look at all aspects of the earth without actually having to dig a hole or excavate through techniques like ground penetrating radar and seismic reflection. Our environmental geology program is set up to really focus on addressing problems that are presented to society. So once again, things like hazards and climate change, and also outreach, building up a broad understanding of the science of geology in the public, which is really critical in these times. Now, our BA degree is a little bit different. Our BA degree, while still having the foundations of science like the Bachelor of Science degree has, this degree is more focused on doing things that are a little more interdisciplinary. It's the route that a lot of K through 12 earth science educators take. It's no less rigorous, it just has a little bit of a different focus to it. And when you get up into your senior year or the final year that you're here at San Diego State, your courses will look a little bit different. They'll be more capstone oriented, they'll be more outreach oriented. They're really starting to try to develop somebody who's working in public policy or working in education or working in outreach or working in government to be a staffer for the federal government. Now that you know a little bit about the programs and what each one can do, so what are the job sectors? Well, we employ people in places like local geotechnical firms and state and federal and local government, places like the USGS, the U.S. Forestry Service, the Bureau of Land Management, and the National Park Service. We have several alumni who are park rangers. What a great job. And then we also feed into large companies. So some of our students, once they've graduated, have gone to work for oil companies like ExxonMobil and Chevron. Now, that may seem a little bit at odds with the environmental aspects of the department, but we feel that by having a strong foundation in geology, we can help mitigate and overcome a lot of the things that larger companies have done in the past. So geology is a great place to start. It's a really fascinating subject. It's an amazing degree to have. There's so many different things you can do with it once you get out. So from here, I'd like to take a few minutes and introduce each one of the different faculty members that you'll interact with during your time at San Diego State. Our program is staffed with experts across all subfields of geology, things like volcanology and sedimentology and geophysics and quaternary geology and earthquakes, computational modeling, hydrogeology and water. We have it all. We're a very broad spectrum department, and as you'll see from the introductions to the faculty and meeting Dr. Gillian Maloney a little bit later, we really are invested in educating the public and educating you on what geology can do for you and why you should be a geologist. I'd like to take a few minutes to introduce you to our faculty. First of all, you've met me. My name's Alan Gons. I'm the current department chair. My interests are focused on how the surface of the Earth has evolved over the past 2 million years through the application of shallow Earth geophysical systems. My work often focuses on areas where humans and societies of various ages have left traces on the landscape. Currently, I'm working in San Diego, South Dakota, Massachusetts, Australia, and New Zealand. Dave Kimbrough is the current undergraduate advisor and previous department chair. His research is centered on the evolution of circum-Pacific mountain belts. His more recent work is focused on episodic volcanic flare-ups in the geologic record and the potential impact on climate change and the evolution of life. He's conducted field-based projects in North and South America, New Zealand, Antarctica, and Japan. Kim Olson is the current co-director of the San Diego State University of California, San Diego Joint Doctoral Program in Geophysics. His expertise is in large-scale numerical modeling of earthquake rupture and wave propagation, strong ground motion prediction, explosion seismology, and geophysical exploration. His current research projects take him to places including California, Chile, Peru, North and South Korea, Japan, and Iceland. Shuo Ma is the current graduate program advisor. He is a geophysicist interested in earthquake source mechanics and associated ground motion and crustal deformation. He is also interested in tsunami generation and studying the physics of large tsunamis generated by subduction zone earthquakes around the world, primarily in Hawaii, Alaska, Japan, and Indonesia. Tom Rockwell is a paleoseismologist and structural geologist who uses soil stratigraphy and geomorphology combined with radiometric dating to assess rates of fault activity, determine recency of faulting, and date past earthquakes. He also works in fault zone architecture and processes as they relate to questions of dynamic rupture during earthquakes. He currently has projects in California, New Mexico, Spain, Portugal, Germany, the Czech Republic, Israel, Jordan, Turkey, Panama, Chile, and Argentina, just to name a few. Gillian Maloney is a marine geologist who seeks to understand Earth processes on and beneath the seafloor, as well as in coastal areas. Her research includes submarine earthquakes and landslides, which can present hazards to human life and infrastructure. She's also interested in the geologic aspects of submerged ecosystems and archaeological resources, which is important for cultural heritage assessment and preservation. She is currently working in California and Oregon. Matthew Weingarten is a hydrogeologist. His interests are focused on understanding how fluid flow and fluid injection can cause earthquakes, dynamic modeling of permeability, and subsurface permeability at the crustal scale. His work is important in understanding the impacts of hydraulic fracturing and injection of fluids into the subsurface for disposal and sequestration of CO2. He is working in California and Oklahoma. Barry Hannon is the faculty resident isotope geochemist. His research is focused on the origin and evolution of the Earth's mantle. He utilizes isotope geochemistry to probe the mantle through the study of volcanism along the mid-ocean ridge system, at oceanic islands and in continental flood basalt provinces. His current research is focused on the southeast Indian Ridge in the Tasman Sea between Antarctica and Australia, and Turkana on the East African Rift. Vic Camp is a petrologist and volcanologist interested in the petrogenesis and tectonics of continental magmatism. His recent work is on the early history of the Yellowstone hotspot and its extensive magmatic system in Oregon, Nevada, California, and Idaho over the past 30 million years. His background provides examples and analogies applicable to his position as a lecturer for general education courses in natural disasters and courses for geology majors in petrology and volcanology. Kevin Robinson is one of the department's long-term lecturers. He teaches oceanography, environmental science, introduction to geology, and historical geology. He also co-leads the annual departmental field trip to the Grand Canyon for second-year students. Isabel Sacramento McGilton is one of the department's long-term lecturers. She teaches natural disasters, intro to oceanography, and courses for science education, as well as working with our undergraduates and the outreach program called Show Me Geology. Rob is one of our many alumni who spends a portion of his time assisting the department. He is a retired geological engineer for San Diego and uses his life experiences to teach geological engineering for us, as well as assist with the department's many field trips. Kip Herring is another one of our alumni and a retired oil company executive. When he's not spending time with his polo ponies, he teaches our petroleum geology courses and oversees the IBA team, which has had great success under his leadership and brings global recognition to the SDSU geology programs. Rafael Almeida is a structural geologist who was born in Venezuela and held student, research, and teaching positions in New York, Singapore, and Ecuador. His current research has focused on mountain building and deformation in the Himalayas, in Nepal and Bangladesh, as well as studying deformation processes of the Andes and basin development in the Four Arc region of South America. He will join SDSU in January of 2021. Samantha Bova is currently a postdoctoral research fellow in the Marine and Coastal Sciences Department at Rutgers University. She'll join the SDSU Geology Department in fall of 2021. As a paleoceanographer, she analyzes sediment from the ocean floor in order to understand past changes in the Earth's climate, utilizing a range of geochemical techniques. In July 2019, Sam led a team of 33 scientists on a month-long ocean expedition to collect cores from offshore Chile that will be utilized to reconstruct oceanographic conditions in the Southeast Pacific and history of the Patagonia ice fields. I'm going to turn the floor over to Dr. Gillian Maloney. Gillian is our marine geologist, and she's going to tell you a little bit about the educational programs we have in the Department of Geology, and a little bit about how she views the educational experience within our program. Gillian, it's all yours.
Hi, I'm Gillian Maloney, and I'm a geology professor at San Diego State University. I'm out here in the rain in San Diego today, which we don't get too much of, but I teach a class called Water and the Environment, where we talk about California water issues and San Diego water issues, and the various properties and parameters of water and the water cycle. We just went through a really bad drought here in 2011 to 2016, but we got through that. And now this year we're getting a lot of rain, which is great. But oftentimes when we get a lot of rain in California, we get flooding and other hazards associated with that too. I also teach a class for geology majors called Sedimentology and Stratigraphy, where we look at modern sedimentary environments and then think about how those would be constructed in the past stratigraphic record. Right here in my yard, we've got a bunch of these nice rounded clasts that indicate a good amount of transport and erosion down a stream system. These are actually called Poway clasts, and they were sourced from volcanic rocks in Mexico and then translated up here through tectonic processes. So they're found all around San Diego. We look at some of those things in that class. And then the other class I teach is seismic stratigraphy, and that's where we use sonar data to image the layers of sediment and rock beneath the ground surface or beneath the seafloor in order to learn things about the stratigraphic history or the structure of those units that otherwise we wouldn't be able to see.
Thanks, Gillian. As I mentioned and as she highlighted, we do a lot of our educational activities through learning by doing, experiential learning. So I'd like to show you a few more examples of what we do within the department to teach our students the fundamentals of geology. Now that Gillian has given you an introduction to how we teach geology, let's learn a little more about the department's activities. Students in the geology degree programs learn through various techniques. Some of these are traditional in-class lectures. The classroom lectures serve to lay the groundwork and provide the theoretical basis for each topic. Our lectures are often paired with homework sets to reinforce the concepts introduced in lectures. Most of our classes, especially those for majors, are supported by either lab or field work. In this instance, students are working with our 18-foot stream table to model how streams work based on changes in slope, materials, and the amount of water. Southern California is a natural laboratory for geologic processes. We strive to introduce our students to those environments that most students only see in textbooks. In this image, Dr. Tom Rockwell is holding a lecture while standing on the surface trace of the San Andreas Fault at a location he has been studying for well over 30 years. There's nothing better than seeing it in the field with somebody who has seen it in the field. We encourage students to use various types of technology to enhance their experiences in the field, lab, and classroom. Photography is a classic tool of geologists, and it serves as a mechanism to record details of location. We teach students how to critically evaluate aspects of a landscape from in-person experiences and then again from imagery. This results in a skill set that allows assessment of new landscapes from pictures and also understanding what those pictures mean to us and what we see when we're out in the field. It helps sharpen our eye. San Diego State University is located within driving distance of some of the world's best and unique geological sites. We have the capacity in the department to transport over 60 students with gear from our home base to a remote location for upwards of a week at a time. Each year, Dave Kimbrough leads a field trip for 4 days to the Grand Canyon and teaches students the basics of field mapping and applications of first-order geologic principles using traditional map and compass techniques. It's one of the showcase field trips of our department. This is one of Dave Kimbrough's students using recently gained knowledge on how to measure the attitude. No, not that kind of attitude. It's not good or bad. It's actually the strike and dip of rock formations. This information is used by the student to reconstruct a story of what went on at this site over long timescales. The fundamentals of geology layer on top of each other and allow geologists to unravel the evolution of a location and relate the changes recorded in processes that were operating at various times in the past. Understanding the attitude of the rocks, it's key. It really is one of the fundamental tools that we use on a regular basis. another one of our second-year students at the Grand Canyon learning to record observations. Geologists learn critical thinking and observation skills through hands-on experiences. They're not always in the field, as the student is showing. We introduce our students to principles of geochemistry, paleontology, and mathematical modeling through lab-based opportunities and coursework. Fieldwork, while important, is not the only thing that geologists do and experience at SDSU. There's lots of room for lab-based science and course-based science and computational modeling and all other aspects that make geology an interdisciplinary science. A student visiting from the winterly land of Wisconsin explains what he learned as he was studying the New River in the Salton Sea in Southern California. In this photo, the student is trying to explain why we are standing at over 25 meters below sea level and yet the river carved a deep valley into the softer sedimentary rocks. Understanding how all aspects of the earth and the processes that shape her surface are critical. It often requires a bit of creative thinking, along with an integration of many different topics and subjects from various branches of science. Geology is truly an interdisciplinary and multidisciplinary science and has something to offer for everyone to fall in love with. Come, find your passion and chase it with us. In the department, we do a lot of our teaching through learning by doing, and one way that we do that is to involve students in research programs for our faculty members. Undergraduate research is a very big component in our department. I'm going to turn the floor back over to Dr. Gillian Maloney so she can tell us a little bit about her research program and how she uses undergraduate students to help her fulfill her research objectives. Gillian?
Hi, I'm Gillian Maloney, and I'm a geology professor at San Diego State University. In my lab, we seek to understand processes that happen on and beneath the seafloor in marine and coastal environments, including things like earthquakes and landslides that happen underwater and can cause tsunamis. And we're also interested in the geologic aspects of submerged archaeological sites and ecosystems, including things like how do streams adapt to sea level change. Because the places that we study are located under meters to hundreds, even thousands of meters of water, we first go out and use sonar data, like this chirp sub-bottom system, to image the layers of sediment and rock beneath the seafloor. These provide nice, here's an image off of the Channel Islands showing some folding and faulting. And we can map these all together to look at things like the broader structure and sedimentary history. Sometimes we go out on larger ships, which have a suite of instruments on the hull of the boat, which record information about the seafloor, the subseafloor, and the water column as well. This ship here is the research vessel Ravel, that's owned by Scripps Institution of Oceanography and is docked here in San Diego Bay. Once we collect that seismic data, the sonar data, we go out and take sediment cores. So we drop these long tubes down into the seafloor, they fill up with sediment. We bring them back up on the boat and then open those tubes to learn about the layers that we saw in the sonar data. This cruise is also on the Ravel. This one was off of Oregon, working day and night to collect these cores, but also having time to relax and learn how to tie knots on the deck of the ship. We also collect these cores on land and in coastal areas. So this is San Diego Bay, where students are trying to figure out how recently active some of the faults underneath the bay have been, and if there might be a risk to the local communities here in San Diego. We've also collected these cores in environments like lagoons and ancient deltas to look for events that might be storm or earthquake related. Once we open those cores up, we can learn about the stratigraphy, take samples for grain size and radiocarbon dating. We even have an upcoming project where we're going to use a remotely operated vehicle on the bottom of the ocean to collect samples to match with our sonar data. So a couple of the upcoming projects that we have are going to be in reservoirs in Oregon to look for submerged processes in a stream system and how that relates to archaeology, as well as off the coast of Santa Barbara on the Channel Islands to look at tar seeps using a different type of geophysical data, controlled source EM data. Those tar seeps potentially are also associated with archaeological sites. Thanks for your interest in our lab and the geology department at SDSU.
Thanks, Gillian. That was great. So all of our faculty are involved in research, and all of us take undergraduate students with us into the field. So what I'd like to do now is show you a few examples of some of the research projects that are being conducted in the department and some of the places that we take our students to conduct research with us. Our students and faculty regularly leave campus to engage with the Earth to understand how she works. Through applying various techniques, we operate on land, over water, and through the air to map, sample, image, and record landscapes and measure the processes that are operating today to infer what happened in the past. We integrate all the data collected and use it to constrain mathematical and conceptual models. We use the information and the results of our analysis to understand how the Earth was shaped, evaluate hazards in society, solve problems, and answer questions about what the future may look like based on our understanding of the past. Each one of our faculty members is involved in research and takes students with them to train them in the techniques that are state-of-the-art in that member's field. While some of our studies are very site-specific, it really is all about getting the experience and how you apply all of the courses, lab, and field experience that you've had while you've been a student. The research experience that we provide our students is the culmination in their degree. Most of our students do an undergraduate research project. They work with a faculty member directly to learn how to apply all of the things that they've done while they've been here. So, come join us on one of our research projects. See geology in action. Thank you for spending a few minutes with us today to learn about the programs in the Department of Geological Sciences. We really would like to be able to introduce you to geology in the fall of 2020. So in the meantime, if you have any questions, please see the SDSU Explore website or the departmental website for more information. And of course, you can always reach out to us in person and talk to a departmental representative. We hope you all stay safe and healthy, and we look forward to meeting you in fall. Go Aztecs!